to find f of negative 4 without the remainder theorem, we would simply go up to our equation here and replace x with negative 4, and then just figure out what number that gives us. Now the remainder theorem is saying that instead of doing that, we can find that same value, that same number, by using synthetic division. And it turns out that the remainder that we get from synthetic division is equal to f of negative 4. Now that's the case as long as we have that negative 4 in the box for our synthetic division. And so by putting any number here in the box, the remainder that we get from synthetic division is equal to the value of the function at that point. And so we'll go ahead and fill in our coefficients. So on our x cubed we have a 3, and on the x squared we have a 4. On the x we have a negative 5, and our constant term is 3. So leave ourselves room to write another row and bring that first number straight down. Multiply by what's in the box, 3 times negative 4, and then add down the column. Multiply by what's in the box, negative 8 times negative 4, positive 32, and then add down the column. And then multiply by what's in the box, 27 times negative 4, negative 108, and then add down the column, it's negative 105. So that last entry there in that bottom row is always going to be the remainder. And so the remainder here is negative 105, and according to the remainder theorem, that's equal to f of negative 4. So that's how we find f of negative 4 using the remainder theorem. And we don't have to write out the quotient, just looking at that remainder. So to verify, just go ahead and plug a negative 4 in for x, so we can at least convince ourselves that this remainder theorem worked, at least in this case. So if we just go through and replace x with negative 4, we should come out with that same value, that negative 105. So negative 4 cubed is negative 64. Negative 4 squared is positive 16. So here we've got negative 192 plus 64 plus 20 plus 3. And if we add all that together, we do in fact get negative 105.